In this video, we will solve exponential equations using logs. 2 to the x is equal to 30. Solve for x using base 2. If we were to rewrite this exponential into a log, we have log base 2 of 30 is equal to x. Therefore, x is equal to log base 2 of 30. If we were to use a base of 10, first, we want to take the log on both sides. If two things are equal already, if we take the log on both sides, it should still be the same. So log of 2x, 2 to the x, is equal to log of 30. Using the log rules, we can pull out this x in front, making it x log of 2 is equal to log of 30. Dividing by log of 2 on both sides, we get x is equal to log of 30 over log of 2. If we think about these answers for a second, first answer, which is log base 2 of 30, and then the second answer, which is log 30 over log of 2. Remember, there was another log rule where if we have log base a of b, that's the same as a log of b divided by log of a. So using this rule, we can say that these two answers are the same. Solve for x. We have e to the x is equal to 30. I'm going to show both ways by solving it with log and solving it with ln. If we take the log on both sides, we have log of e to the x is equal to log of 30. Bring down this x in front of the log of e, so we have x log of e is equal to log of 30. So x is equal to log of 30 divided by log of e. If we were to rewrite this as a non-fractional form, we have log of e of 30. Second, if we were to take the ln on both sides, we have ln e to the x is equal to ln of 30. Using the same log rule, pull out the x in the front, we have x ln of e is equal to ln of 30. But we know ln of e is equal to 1. So x is equal to ln of 30. Let's compare the answers in both cases. We have x is equal to log of e of 30, and the other one x is equal to ln of 30. Remember, with the log with the base e is the same as ln. So when you're dealing with the number e in the problem, there is no right or wrong answers of which one to use. Log works, ln also works. However, the number e works out very nicely with ln. So we prefer to use ln when you're dealing with number e. Let's look at the second problem. We have 3 times e to the x over 2 is equal to 21. Let's divide by 3 on both sides. So we have e raised to the x over 2 is equal to 7. Take the ln, because we're dealing with number e again, on both sides. So we have ln e to the x over 2 is equal to ln of 7. Using the laws of log, we have x over 2 ln of e, which we know it's a 1, is equal to ln of 7. Multiply 2 on both sides, so x is equal to 2 ln of 7. So that's the answer for the second one. Consider the equation p is equal to 200 times 2 raised to the 0.04t. Rearrange the equation to give t in terms of p, right? So give t in terms of p. That means what is t equal to in terms of p? So first, write the problem. P is equal to 200 times 2 raised to the 0.04t. In order to solve for t, let's divide it by 200 on both sides. So we have p over 200 is equal to 2 raised to the 0.04t. In order to bring down this t as an exponent, we need to take the log on both sides. So we have log of p over 200 is equal to log of 2 raised to the 0.04t. Using the log rule, we can bring down 0.04t in the front. So 0.04t of log 2, and we have log of p over 200. So all these three things are being multiplied. 0.04 times t times log of 2. So if we divide it by 0.04 log of 2, we'll be able to solve for t. So we have log p over 200, all divided by 0.04 log of 2 is equal to t. Alright, hence, usually in IB problems, whenever you see the word hence, it means use the information from above. Find the value of t when p is equal to 6. When p is equal to 6, so you would plug in 6 on here. So log 6 divided by 200, and then divide that by 0.04 log of 2. Try it on your calculator. When p is equal to 6, you should get t approximately negative 126. Try it on your calculator and see if you can get this answer. Find algebraically the exact points of intersections of y is equal to e to the x minus 3 and y is equal to 1 minus 3 e to the negative x. Then check your solutions using technology. So when it says algebraically, it means show it by hand. Then you can check your answers using a calculator. Alright, so when we're looking for the point of intersections, that means at that point, x and y coordinates are the same on both of the equations. So we're going to set them equal to each other. So we have e to the x minus 3 is equal to 1 minus 3 e to the negative x. We're going to move everything onto on one side. So we have e to the x minus 3, and then if you move that onto the left side, that's minus 1. So we have negative 4 plus 3 e to the negative x is equal to 0. All right. Now, we need to multiply each term by e to the x because we don't like to deal with this negative x. So if I multiply the same thing on both sides, we're not changing the equations. So multiplying, again, both sides by e to the x. E to the x times e to the x, that's e to the 2x, minus 4 e to the x, plus 3. What happens when you multiply 3 e to the negative x by e to the x? Same base. You add the exponents, so it's e to the 0 power, which any number to the 0 power is equal to 1. So you're just left with 3. It's equal to 0. So this is something similar to what we've seen before. If we let y to be e to the x, then we can rewrite this as y squared minus 4y plus 3 is equal to 0. Hold on, pause for a second. Miss Lee, why is this a y squared? Well, e to the 2x is the same thing as e to the x squared, right? So then this e to the x, we let it to be y, therefore it's a y squared. So now this is factorable, y minus 3 y minus 1 equals to 0. Therefore, y is equal to 3 and y is equal to 1. But then again, this is not the end. We have to solve for x. So plug back into what y is equal to. Well, e to the x is equal to 3. E to the x is equal to 1. If we take the ln on both sides, we get ln e to the x, right? Ln e to the x is equal to ln of 3. Pull out this x in the front. X ln of e, which we know is a 1. So x is equal to ln of 3. If you can go from here directly onto here, that's also fine. E to the x is equal to 1. Any number raised to what power gives you 1? X must be 0. Therefore, the point of intersection would be first when x is equal to ln of 3 and figure out the y value. The other one is a 0 and figure out the y value. All you need to do is plug in ln of 3 onto one of the equations, either on here or over here. So e to the ln of 3, what is that? E to the ln of 3 is equal to 3. So 3 minus 3 is equal to 0. If we plug in 0, any number raised to the 0 power is equal to 1. So we're left with 1 minus 3 times 1, so that resulted in negative 2. So those are the intersections. If you were to check these answers using your graphing calculator, you would graph both of the functions, which would look like something like this and something like this over here, right? So then you would check the point of intersections. See if you get a 0 and negative 2, and also ln of 3 and 0. On your calculator, it's not going to say ln of 3, so you need to check on your calculator what is ln of 3. Convert that into a decimal and check the answers on your graph.